Hello good people, welcome back to another math video. This one on factoring expressions, or as we called it today in class, doing a reverse distribute. So a problem might look something like this, telling you to factor like 12x minus 20, or another version of this. We are going to start by finding the greatest common factor between these two numbers, and then we're going to basically take that out of each number and set that up with our parentheses. And when we're done, it's going to look like an expression where we need to distribute. Well, let's get started. So I'll rewrite each of my terms over here, and I have 12x and I also have 20, and then I'll do some factor trees to figure those out. So for 12 I could factor that with 2 and 6. 2 is prime, and 6 I could factor with 2 and 3. Each of those are prime. So my factors of 12x, my prime factorization would be 2 times 2 times 3 times x. And for 20, I could factor that as 2 and 10. 2 is prime, and then 10 I could factor as 2 and 5. So my prime factorization for 20 would be 2 times 2 times 5. So then, if I find my GCF, let's see, they have those in common, and they have those in common. So the GCF for 12x and 20 is 4. Because 2 times 2 is 4. That part should look familiar. So now what we're going to do, this is the part that looks a little different. We're going to take that greatest common factor and we're going to set that outside of these parentheses. And what's going to go inside the parentheses, I'm going to think about it two different ways. A simple way to think about it is I take the original sign right here. That's a minus sign, so I'm going to have a minus in my parentheses. And then I take these factors that I didn't use for 12x right here, multiply those together, and I'd have 3x. Take the factors I didn't use for 20, right here, this 5, and set that in here. So factoring 12x minus 20, I would have 4 times parentheses 3x minus 5. Now to check my work, I can distribute. Well, if I had 4 times 3x and 4 times negative 5, what would I get? I'd get 12x minus 20, which of course that was my original problem. Another way that we thought about this, I'm going to erase my factor trees over here just to give myself some room. Another way that we thought about this was, once I found that greatest common factor of 4, I can then divide each of my terms. So what is 12x divided by 4? Well, 12x divided by 4 is 3x. And what is negative 20 divided by 4? That would be negative 5. And that's another way to think about setting this up. Alright, let's try one more. So in this one, we're being asked to factor 36y minus 5x. So I'm going to set this up the same way. Factors of 36y, factors of 15x. 15x, we might be able to just do that in our head, knowing that prime factors would be 3 times 5 times x. 36, we might have to make a factor tree for that one. Alright, so let's see, I could do 36, I could do 4 times 9, maybe that's one that's coming to people. And neither one of those are prime. 4 I could do is 2 times 2, prime numbers there. 9, I could factor as 3 times 3, prime numbers there. So my prime factorization of 36y would be 2 times 2 times 3 times 3 times y. Okay, well, what do we have in common? Only these threes. So the GCF of 36y and 15x is 3. So I'll set my 3 outside my parentheses. My original factor set up here, my original expression, had a minus sign, so I'll have that in down here. And now, what are the factors that I have left for each of these? For 36y, I have a 2 left right here. I have a 3 and a y. So, let's see. I'll change colors so you can see that. I have a 2, another 2, a 3, and a y. So if I multiply those together, I have 2 times 2 is 4, 4 times 3 is 12, 12 times y is 12y, and my factors left for 15x, I have 5 and x, and those multiplied together are 5x. To do my check, I could just distribute the 3. 3 times 12y, that's 36y. 3 times a negative 15x is a negative 15x. And that checks out with what we have above. So we really just have kind of one new step here, and that is after we're finding the GCF, we're setting up what looks like an expression that we would have to distribute. We have that GCF out front, right here, and then we take our leftover factors, we multiply those together to set up what's inside the parentheses. Alright, hope that helps. Have a great day. We'll see you tomorrow.